watching this video because you're interested in the engineering career. So let me tell you more about 4 interesting degrees we present at the School for Electrical, Electronic and Computer Engineering at the Faculty of Engineering in Potchefstroom. My name is Johan, and let me share with you some important information about the degrees we present. So I've received a list of questions on my laptop, and I'm going to tell you more about the 4 degrees by answering these questions. First off, what are the 4 main degrees you present at the School for Electrical, Electronic and Computer Engineering? Well, we have Electrical Electronic Engineering, Computer Electronic Engineering, Mechatronic Engineering and Electromechanical Engineering. The focus of Electrical Electronic Engineering is on energy. The focus of Computer Electronic Engineering is on information. The focus on Mechatronic Engineering is on automation and Industry 4.0. And the focus of Electromechanical Engineering is on large industrial systems that you will find in mines, for example. The next question is, what is the difference between Electrical Electronic Engineering and Computer Electronic Engineering? Electrical engineering is about energy, the generation of energy, distribution of energy, storage of energy, and the provision of that energy to an end user. Computer engineering is about information, and similar to electrical engineering, it is about the generation of information, the distribution of information, the storage of information, and the provision of that information to an end user. So these 2 degrees are similar in one respect. Something is generated, it's transported, it's stored, and it's provided to an end user. An important question we often get is, what is the difference between electromechanical engineering and mechatronic engineering? In electromechanical engineering, we find a mixture between electrical systems and mechanical systems, such as you'll find in mines, transport networks, such as trains, and large industrial systems. Mechatronic engineering is a mixture between electronic engineering and mechanical engineering, or electronic systems and mechanical systems. And the energy used is much lower than for electromechanical systems. You'll find mechatronics in smaller systems such as vehicle manufacturing plants, unmanned aerial vehicles such as drones, and all smaller robotic systems that you can see around here everywhere. Still, another interesting question is, what do I learn when I study electrical engineering? Well, because electrical engineering is all about energy, how it's generated and applied. Just briefly, you will learn about energy conversion, such as electrical motors, energy distribution, such as the large networks you see when you drive along the highway, power electronics, energy storage and how equipment is protected, for example. You will learn about how energy is applied, such as in alternative energy solutions, large solar systems that you see on the roofs, and even the larger ones that you encounter in the Karoo. You will learn about large power stations, and you will even learn about electric cars. Here's an interesting question. What do I learn when I study computer engineering? Well, in all our degrees, you will learn all the basic skills in science and maths. You will learn how to program and how to design software solutions. You will learn how to design computer networks and communication. You will learn about hardware design and embedded systems. And you will learn how to design and implement large-scale systems that you will find, for example, in the Internet of Things. Another common question we get is, do I need specific training, such as programming, or should I be able to do engineering design? In other words, the subjects you'll take at school before you start studying. And the answer is really no. Apart from the basic entry requirements in maths and science, you don't need any specific training. It's always to your advantage to have those skills, of course. But you will get these skills, all the skills required, when you study at our school. Moving on, the next question is, how do I know I'm a good engineering candidate? This is not a simple answer, but you should like to come up with solutions to problems. In other words, you should be able to listen to people, understand their needs, and design new solutions to their problems. You should be able to use mathematics and science and programming as some of the tools to solve these problems that we've just spoken about. You need to take up the challenge of learning new skills, such as engineering design, software skills, for example, modeling and simulating, for solving problems and modeling new solutions to unknown problems that people have not been able to solve before. And then you have to manage people to get the job done. A very important question is, are your degrees any good compared to international standards? This answer is an easy one. Yes. Our degrees are all Excel accredited, which means that you're able to work in all large countries, including America. Our engineers are currently working in large companies all over the world and are making a difference because they're multi-skilled and well-adjusted. So the answer is really simple. By all means, we can compete internationally.
We trust that you now have a good overview of the degrees we present at the School of Electrical, Electronic and Computer Engineering. If you're still curious and you need more information, kindly follow the link below. Please feel free to contact me or any of my well-informed colleagues for more information. We wish you all the best and hope to see you at our school in the near future.